Today we're going to continue looking at solving trig equations by factoring, but this time instead of using our x box, we're going to be factoring out one single term. So whenever we're factoring something, we want to make sure that one side of our equation is equal to 0. So for number 1, we already have one side of the equation equal to 0, so we don't need to move anything around. So for this first problem, we're trying to see, so there clearly is an A and a B, but there's no C here, so that's why we're not using the x box. Instead, we're going to see if there's anything we can divide out of both of these terms. So both of these have a cosecant, so I can take a cosecant of x out of both of them. So that's going to go on the outside of my parentheses. And then when I divide each term by cosecant, what I have left over is going to go inside the parentheses. So if I have cosecant squared divided by cosecant, that leaves me with just one cosecant. If I have a root 2 cosecant divided by cosecant, the cosecants cancel out, so this is just left with minus root 2 equals 0. And just like last time, now we're going to just set both of these two equal to 0 and solve two separate equations. So we have cosecant of x equals 0, and we have cosecant of x minus root 2 equals 0. So whenever we have a reciprocal like cosecant, we know that we're going to have to flip this to turn it into sine. So right now cosecant is 0 over 1. To flip it, this is going to turn into 1 over 0, which is undefined. Looking at our trig ratios, because this is clearly something not inside of our chart, this is going to be something we use our y over r for. This is telling us that our r has to be 0, but we know that r is always 1 on our unit circle, so it's impossible for r to be 0. So this is another one that has no solution because it is impossible for r to be equal to 0. Let's look at our second equation. So for this one, I'm first going to add root 2 to both sides to get cosecant by itself. And now that I have cosecant by itself, I'm going to find the reciprocal to turn it into sine. So now it's 1 over root 2. And remember, we can't have a root at the bottom, so we're going to multiply both sides by root 2 over root 2, and this gives us root 2 over 2. So we're looking for when sine of x equals, this is a positive root 2 over 2. So just like before, this is going to be two parts. We want positive sine, and we want to use the chart to find root 2 over 2. So in your chart, if we look for root 2 over 2, this is when our theta is pi over 4, and our sine value is positive in the quadrants 1 and 2. So in quadrant number 1, we're starting off at 0, which means our x value will be equal to 0 plus pi over 4, which is pi over 4. In the second quadrant, we know this is pi, which we can rewrite as 4 pi over 4. And then when we are going to the second quadrant, we're subtracting, because it's going from 180 towards 90. So 4 pi over 4 minus pi over 4 is going to give us 3 pi over 4. So those are my two answers for this problem, because this one does not have a solution. Okay. For number 2, we're going to do something similar. So first, recognize that this is not equal to 0. What we don't want to do here is you do not want to divide by cosine. Because when we do that, we're actually going to lose one of our answers, because we also want to see, what happens when cosine of x is 0. So what we're going to do here is we want to move everything to one side. So I'm going to subtract root 2 cosine x from both sides, so that I'm just left with 0 on the right hand side, because these cancel out. And now I have two terms on the left hand side. So we're going to do what we just did up for number 1. We're going to see if I can divide something out of both of them. And both of these have a cosine, so I'm going to take a cosine out of both of them. When I divide this term by cosine, it's going to leave me with 2 sine x. Minus when I divide this term by cosine, it leaves me with root 2. And this is equal to 0. So again, here are my two terms, my two expressions. I'm going to set them both equal to 0. So I have cosine of x equals 0, and then 2 sine x minus root 2 equals 0. So cosine of x equals 0, this is not in my chart, so I know it's quadrantal. And cosine is x over r, so I'm looking for when x is equal to 0. So on my unit circle, x is equal to 0 right here and right here. And so that is, in radians, 90 degrees is pi over 2. And 270 degrees down here is 3 pi over 2. So those are my two answers for this first equation. I'm going to do the same thing for this one. So let's first solve for sine. So let's get sine by itself. We have sine of x is equal to root 2 over 2. Again, this is positive. So we're going to break it up into our two parts. We know sine is positive in the first and the second. Let's look at our chart. Sine is root 2 over 2 when your reference angle alpha is pi over 4. So in the first quadrant, we just add pi over 4 to 0, which leaves us pi over 4. And in the second quadrant, this is again 4 pi over 4. And we're subtracting, so that gives us 3 pi over 4. So for this problem, here are our answers. We have 4 different answers for problem number 2.